hope all of you are in good health. There's one student who just texted me that saying that he's not feeling well. So hope the rest of you are feeling well, inshallah. So as promised on last Tuesday, today will be the time for presentation, right? So we'll start with the first group, inshallah. So without wasting any time, let's go straight to the agenda of presentation. So each group are given roughly 10 to 15 minutes only. Did I mention this before? And you didn't ask. Why didn't you ask?
You did mention 20 minutes.
I said 20 minutes. Is it including Q&A or no? No. Okay, never mind. Let's give you 20 minutes. Okay, so who's the first group that will present? Who are doing LED?
My group, madam.
Okay, Nick. So you can share your slide. Then I will start the time. I will have a timer. What's my timer? Who's in your group?
Iqmal Hamzi, Azimuddin, Anas, and Hazim Salam.
Okay. There are people who coming late. So okay, your time start now. So you just start sharing. After 20 minutes, whether you finish or don't finish, I will stop you.
Anas, can you share the slide? Assalamualaikum warahmatullahi wabarakatuh.
Sorry. Okay, sorry, go on.
Assalamualaikum warahmatullahi wabarakatuh. Today our group will present about LED. LED is a short form for light emitting diode. It is a semiconductor optoelectronic device, and it consists of compound semiconductor from group 3 and group 5. LED can emit lights when there is current passed through it, and different light color will be produced if different semiconductor materials with different energy band gap is used. The advantage of LED are it is energy efficient because consume very low amount of power. Second one is long life cycle because it can last for 50,000 to 10,000 hours and no warm up time. It can turn on and off instantaneously. Next, I will pass to Ikmal.
Okay, moving on to the how LED works. LED working principle is the same as the regular PN junction diode, but LED use the direct band gap material, which I will explain later. LED only works on forward bias. Forward bias here means the P-type is connected to the positive terminal, and N-type material will connected to the negative terminal. When this happens, the free hole in the P-type will be pushed towards the diffusion region, and the free electron in the N-type when this happens, some of the electrons and hole will be combined, and some of them will be diffused. The recombination of the electrons and hole will release energy in the form of photon. This process is called electroluminescence effect. Right, next slide. Okay, this is the direct versus indirect band gap. as I mentioned earlier, LED use the direct bandgap material. Direct bandgap means the minimum of the conduction band is directly above the maximum of the valence band. Thus, when the electron want to jump to the electron from the conduction band want to jump to the valence band, it does not have the change in momentum. Thus, it release energy in the form of photon. In contrast with the indirect bandgap material, there will be the change in momentum. Thus, it will release energy in the form of photon, which is heat energy. Usually, the direct bandgap material come from the group 3 and the group 5. Mm, I think that's all from me.
Bismillahirrahmanirrahim. You can hear my voice, right? Clearly.
Yes.
Hello.
Yes.
Okay.
Yes.
Okay. So I will proceed with the different type of LED. So the first type is the through hole LED. This is the most common LED used by the most of the people. It consists of multiple shapes and size. Have two leads, which is the positive anode and negative cathode. So this type of LED have different colors, but not multiple colors, but uh, one LED, one colors, but many colors. Okay. The second one is the SMD LED, stand for surface mount light emitting diodes. This is the a very small size LED. It's already mounted on the circuit board. So it has various type of SMD. Depends on the model. Uh, uh, there is a model that have many SMD LED and depends on the model lah. Okay, the third one is next slide. Then the third one is the bicolor LED. So the bicolor LED is the multiple color LED, which one LED can produce many colors. For bicolors, it can produce two colors, which is red green or yellow green. It have three legs, which is two anodes and one cathode. And the fourth one is RGB LED, also the multiple colors LED, which have a red, green, and blue LED, mostly used by the designers for decoration purpose in computer cases, motherboard, and RAMs. Have four leads, which is three anodes and one cathode. And the last one is the next slide. The last one is the high power LED. So any LED which have the power level greater or equal to 1 watt is considered as the high power LED. And of course, this high power LED are brighter than other type LED, but it consume a lot of power due to the high power consuming. So it needs to be used with the heat sinks. Heat sinks here is the cooling tools, and it is often used in flashlight and spotlight. I think that's all from me. Proceed with the
For LOD performance parameters, we have 7 here. So for the first 4, which are the luminous flux, luminous intensity, luminous and illuminous, we can see to the next slide. So for luminous flux is the measure of the perceived power of light. The the unit is in candela, and luminous intensity is the quantity of visible light that emitted in unit per time solid angle. So for illuminance is the amount of light falling into the surface area, and the luminance is the intensity of the emitted light on a given area and direction. So when we want to choose the LED, it depends on the application. For example, we want uh, to choose a LED bulb that has a higher candela luminous flux. So another example, if we want to choose a spotlight which is focused on the surface, we should focus on the illuminance or lux. And then if we want design the light, especially the brake light of the car, we want it to have a higher intensity. So we should focus on luminous intensity, which is the lumen. Previous slide. So for the fifth one, which is the luminous efficacy. Luminous efficacy is the measure of how well a light source produces visible light. Next slide again. So as you can see the graph, the y-axis is the luminous efficacy. On the right, on the left, luminous efficiency. It is basically the same. Luminous efficacy just in terms of ratio. So across the wavelength, we can see that our eyes, human eyes, can only, mostly perceive light in the range of 550 nanometer in the middle, which is the green light. So we want to choose, we want to design the LED that has luminous efficacy in this region. Previous slide. So the next performance parameters is the LED color. So the different wavelength range and material produces a different color of LED. Next slide. So for example, if we want to choose the LED color of blue, we can choose zinc selenide for our material. So the bandgap of zinc selenide basically is 2.59 electron volt. So we can put the bandgap of the zinc selenide into the equation. The H is the Planck constant and the C is the speed of light. So we calculate, we get the wavelength of 479 nanometer, which is, if you can see in the left spectrum, is in the blue region. So previous slide, the last performance parameters is reverse bias voltage protection. As we all know, the LED works in the forward bias, but what if we accidentally or somehow the LED has a reverse bias voltage? So for low reverse bias voltage, it's still okay, but for large reverse bias voltage, it can permanently damage the LED. So we should have some kind of protection circuit in the LED. Okay, Anas.
Okay, Bismillah. I will talk about the invention of blue LED, which is the LED that leads to the current LED technology. Okay, blue LED is the hardest to make because it is made of material gallium nitride. And gallium nitride is hard. This is not hard to make, but it is hard to make for the perfect material for the LED, because it is very hard to dope, and it is very hard to make it very hard to make the material to be high quality. So it is being perfected by the three figures, which is Shuji Nakamura, Hiroshi Amano, and Isamu Akasaki, that they created a two-flow MOCVD, which is material organic chemical vapor deposition, to create the high quality gallium nitride. Also, in 1993, they also invented the heterostructure LED for higher rate of recombination, because we can see that if more electrons, more recombination occurs, more photons will be emitted. So it will give a more higher efficiency of the LED, a blue LED. Okay, so why blue LED is important? Blue LED is important to us because in our everyday life, when we see our screen, to perceive white, we have to have a blue LED, because white color is a combination of red, green, and blue, as we can see in the pictures there. So to make a white color, there is two methods. The first one is RGB method. It requires an RGB LED that has the three lists that, like the brother Mirza just said just now. This method uses additive color method, which is we can control the intensity and the brightness of each color to get the white color that we want. So it is very flexible, and the exact control of the output color can be controlled. Okay, so for the second method that we can get white LEDs, it is through phosphor method. Phosphor method is the most common that we see if we want to buy a white LED. As in the picture right there, that is the phosphor white LED. It uses a blue LED as just a blue LED with a phosphor layer on top of it. So so it means that the phosphor layer, it replaces the R and G, which is the red and green in the white color. So I think I will pass to Brother Hazim Salam.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. For the Islamization part, I would like to take from Surah An-Nur in the verse of 35. In this ayah, Allah explains himself as the Nur, which is in this ayah you can see Allahu Nur as-samawati wal ard. Allah is the light of the heavens and the earth. And then from the Masal Nurhi Kamishkati Fiha Misbah until the part of Walau lam tamsasu nar, this is actually what kind of light that Allah describes himself, but this is actually very surface of the knowledge, because many mufassir explain that this ayah is actually esoterical, which means it is intended to be understood by only people with special knowledge. So basically, from the part Masalun Nurihi Kamishka Fiha Misbah and until the part Walau lam tamsasu nar, the light is explained in form of a niche which is burned by the olive oil, which olive oil is the purest form, because if you see in the min sajaratin mubarakah, min sajaratin from the tree, mubarakah is blessed. So sajaratin mubarakah is a blessed tree. Zaitunatin refers to the olive. La sharqiyati wa la gharbiyati, located neither to the east nor the west. In this ayah, Allah many mufassir explains that uh, the olive tree actually located in the middle, and its tree does not does not uh, basically move, not move. It's not located north to the west, or north to the east, because uh, the whole tree will get the most exposure of the sunlight. And the olive, it works such that if it gets the most exposure to sunlight, then it will produce the most pure of olive oil. So uh, and then the part of uh, yakadu yakadu zaitha yudhi'u walau lam tasashu nar, whose oil will almost glow even without being touched by fire, meaning the oil itself almost glow even without being lighted by upon a fire. Nur ala nur, Allah describes himself as the light above all light. So we as the humans may have the capabilities to produce and generate LED, but it is Allah who gives humans the knowledge in which the nur for human to be able to produce LED. Yahdillahu li nurihi man yasha. Allah guides whoever He wills to His light, but this does not necessarily means that we have to wait for the sign, because as you see, Allah already explained in the next verse, وَيَضْرِبُ اللَّهُ أَمْثَالَ لِلنَّاسِ. And Allah sets forth parable for humanity, Allah sets example for humanity. وَاللَّهُ بِكُلِّ شَيْءٍ عَلِيمٌ. Allah has perfect knowledge of all things. Allah is an alim, in which He knows everything. So what's good comes from me, and what's bad comes from Allah, and what's bad comes from my poor self. So jazakumullah for that. Thank you.
Okay, thank you very much, brother, for the presentation. Okay, now let's go for Q&A. Let's start from the floor first. The students, do you have any question?
I have a question again.
Not you. I mean, you are supposed to
Okay.
answer. Your group are supposed to answer the question. You are the expert now. You're supposed to ask question before your assignment to me. So so the rest of you, the other students, ask question. Each group have to ask question. Otherwise, I will deduct marks from your group. Okay, who wants to start first?
Excuse me.
Yes.
Yeah. Do all the type of LED use the same PN junction?
Okay. Okay, so somebody from the group, you need to answer that question.
Yes. Hello, someone else. Hello, Assalamualaikum.
Salam, go on, Mirza.
Sorry. Yeah, I think all types of LED are using the same PN junction, because inside the LED we have the P-type semiconductor and N-type semiconductor, and the working principle is quite the same. It's just that maybe how it modify. I don't know how to say. But for the PN junction, I think it use the same type of PN junction for all types of LED.
But Anas was saying something else in the presentation. He mentioned about there's a heterostructure. So what does it?
For the hetero and homo, because there is a type of LED that use the same type of what we call homojunction and heterojunction, right? There is a LED that use the same material, which is for homojunction, and there is a LED that we use different type of material to adjust the wavelength.
So you do heterojunction to adjust the wavelength?
Yes, to get different type of colors, I think.
Can I try to answer?
Uh-huh.
Yeah.
The color we get is due to the different band gap from different materials. So the heterojunction is uh, used to different materials, and as we can see at the slide unless just now, as in the middle, the band gap is small, so more the recombination is need lesser energy to happen, and the electron and holes from N and P type that will diffuse to other side may fall to the middle and make it more efficient, I think.
But does it matter if the energy for recombination is small for the recombination rate?
What?
Does it matter? Because Nick was saying that, oh, then it's good when you have hetero structure, the energy for it to recombine is less. Therefore, you are suggesting that it will increase the recombination rate. Is that right?
Yes, madam.
Yes, madam.
The smaller the band gap energy, it will increase the recombination rate.
Increase the.
Think before you answer. If you don't understand my question, ask me.
So the question is like the rate is mean like more recombination you mean, or
Yes. So is it more recombination when you have smaller energy?
I think no.
So,
recombination
then because
is
your
due
answer
to
before was misleading. So answer. So why no?
I think the rate of recombination is due to the carrier concentration.
Where?
Because at the P or PNN junction. Because more doping means more, and more carrier concentration means
what's the
more
point of
free.
having? What's the point of making it a heterostructure then? What's the main point of painstakingly make it heterostructure LED? What's the point? What's the main point?
It is for the active layer, madam. The
It is
active layer
what?
for the active layer.
What is the main point of making the LED heterostructure? Why do they make it? The main reason. Anybody in the group?
I think to produce different wavelength, madam. Because different wavelength generates different color. Therefore, using
I can still have a homo junction with the color that I want. I can still make the, I want to make a color, but just with the homo junction, I can have it. I can do it. So why do I need to do hetero structure? You actually answered before, but it's not clear. But now I'm asking the question again to make it clear, then if you understand, you're supposed to be able to answer. Jawapan tu ada kat dalam gambar tu.
To make the hole and electron easier to recombine.
To make what?
The electron and hole easier to recombine.
How does it make it easier to recombine?
Because the band gap is more smaller.
Nothing to do with the band gap kan? Saya kata tadi jawapan tu, the recombination rate, nothing to do with the band gap, the energy. Oh, dah betul separuh. 50% lah. Make it. So, ada orang nak jawab?
What I think is, madam, the hetero structure will make the P and N becomes closer, so that the electrons and holes is easier for them to recombine.
What do you mean closer? Because I don't understand. Okay, let's keep this question. Next question from the floor. I will tell you the answer afterwards. Okay, any question from the student? The other groups, only one group have, so Haris from which group, I don't know. The rest of you from other group ask question now. So I will jot down that Haris group already asked question. The rest of you, although I give you 1 minute or 2 minutes to ask question. So that's saya tidak mark.
I have a question, madam.
Okay, Farhana.
How is the energy band diagram? Can you show the previous slide? Okay, how does the light produce? I'm not clear about that.
Okay, please answer.
The light produced when the recombination occurs. That's what I understand. During the recombination, the electron and hole will release energy in the form of photon or light energy.
Does silicon also produce photon? Or?
No, because silicon is indirect. When the indirect band gap, it will be changed in momentum. Thus, it releases energy in the form of phonon, which is heat energy.
Oh, okay, okay.
Okay, thank you. Next question from the other group.
I have a question.
Go on.
This one, this working principle is working in direct band gap, right? So from the figure A, the photon is produced by the recombination or is being collected? Because I'm confused with the arrow there, arrow of photon.
It occurred due to recombination.
It's not clear. Your internet is not clear. Repeat.
It occurred due to recombination.
Recombination due to the release of photon or accept of photon?
Yeah, when the recombination occur, the light energy will produce.
Produce photon, right?
Yeah.
So, okay. So the diagram is the arrow from the diagram A show that the photon get to inside, right?
Uh, the photon can be produced in random direction. It does not necessarily to the.
But you understand the sister's point. The figure, I think you take a figure from for maybe generation. The arrow of the photon should be normally going out because it's releasing. Okay, good job, sister. You pointing out an error. Okay, next question. Ada groups. So Munirah tadi dengan Farhana. Who else? Which group haven't asked question? I give you one minute.
All group already asked question.
All group already asked question. Okay. All right, my turn to ask question. Okay, brothers. The question is to Hazim. Hazim, which one is better to make a white LED? Is it to RGB or the phosphorus method? Hazim. Which one is better?
The phosphorus method.
Why?
Because the phosphorus itself is it's an how do I say element it's already yellow, so the blue light when it combines with yellow, it will produce the white light. So that's not necessarily we have to combine many different colors to produce white light, because the phosphorus itself is already yellow.
So why is it better? Because phosphorus is yellow.
It replaces the red and the green LED light. Sorry.
Repeat, I cannot hear you.
The phosphor replaces the red and the green. So we does not necessarily need to have red and green color, red and green light, to and also blue to produce white light, white LED, because the blue light when it is when it meets the phosphor, so it will also produce white light.
Okay, basically what you want to say is it's a simpler process. Is that what you're saying?
Yes, it's a simpler process.
It's easier if you say you answer like that. Okay. All right. Question two. There's no right or wrong. The RGB method is also can be used, and many people also use the RGB method. But most of the, if you buy the LED lights at home, the white light, they are using the second method, the phosphor method. Okay. Next question to Anas. Can you explain how do we know an LED whether it's efficient or no?
Mana tu? Ni. We can see if it is efficient or not based on the brightness versus the wattage that it pulls. The brightness we can apa lagi? We can apa nama saya bahasa Inggeris? We can measure the brightness in power in joules also, so that the ratio we can take the ratio of the power output and the power input to it. So the efficiency, if it is close to 1, it means that it is efficient. It is efficient. If it is lower lah. The lower the number is, the less efficient it is.
What do you mean by the number is 1? But because you are let's say you are talking about the brightness over the voltage. It's 2 different unit, and how do you get 1?
I mean the power output, the brightness that we can measure in joules, in watts. We can in watts, and then the power input. That's how I understand it. I don't really.
Okay, but yes, you can also roughly measure the efficiency by that, but I don't think you can get the 100% looking from that, which are not presented here. Efficiency also number of, which is not, your team member didn't explain about the efficiency, whereby number of electrons and holes created versus the number of photons coming out. So if you, for every recombination of electron and hole, you get, for every recombination, you get 1 photon, and that's 100%, right? But as we mentioned before, there are also defects. You can have non-radiative recombination, which then reduces the efficiency. Okay, next question to Mirza. What is MOCVD? Senyum manas, buat dia mentang. Okay, Mirza.
Apa ni? Metal organic chemical, MOCVD. Metal organic chemical vapor deposition, I think.
Metal organic, right?
Metal organic, yes.
Yes. Tadi Ana sebut material organic. Kalau tak percaya boleh balik recording. Okay, so at least you got it right. So what is it? What do we use it for? Use it for fun? No?
No. For, like Anna said before, is to produce blue light. Blue light.
How do you produce blue light from MOCVD? Anas nak tolong?
It creates the material itself, the gallium nitride itself.
It creates the material? I thought Allah created the material.
Oh, mak.
Huh? Macam mana?
Agak lupa lah aku. It combines lah. It creates the crystal of the material, the film, the crystalline of the GAN.
Okay, so basically it makes the, remember I explained the class kita buat kuih lapis kan, where we make the structure of the crystalline structure, to, you know, the material itself Allah created, but to make it into a crystal structure the way we want to susun, make it layer by layer, how the equipment that we use is the MOCVD. Okay, siapa dalam group ni, saya tak tanya lagi, Nick lah, Nick, what is the difference between lumen and luminous flux?
Lumen and luminous flux.
Ada difference tak?
Lumen is the unit for luminous flux, which luminous flux is the parameter that we use to measure the power of light, and lumen is the unit. I
Do you
think
know
that
how?
is
Do you know how do we measure the luminous flux? How do we measure it? Do you know? Tak apa. You don't have to answer. Saja je saya tanya soalan yang keluar sikit. Okay, last question. Saya last Azimuddin kan, saya tak tanya kan?
Yes.
Okay, Azimuddin. So looking at the how the LED works, right? Your friend explain how it works. Apa yang kawan awak yang explain tadi tu?
Ikmal.
Ikmal. Oh, Ikmal pun saya tak tanya soalan lagi. Okay, then he explains that you have recombination and you have diffusion. My question is, before recombination, do you have diffusion before recombination for the electron and holes? Do you have diffusion? Does diffusion occurs before recombination for the electron and holes?
I think yes.
Why? Is it occur before, simultaneous, or after, or how does it, what's happening? Because it's not clear from the presentation just now.
Because the free electron need to diffuse before recombination.
Why does it have to diffuse first? If you can answer your friend in the group.
I think because the recombination is due to higher due to the concentration, right?
So your friend answer now if you cannot answer.
Because it follows the concentration gradient. The first one should be the diffusion, in which the electron will move in the n part will move to the p side. So the holes will move from the p side to the n side.
So my question was asking, why do you need diffusion for recombination to occur? Why? Because answer.
Because diffusion comes first from before the recombination.
Yeah, why? My question is why? Why you need to have this diffusion first? Jawapan tu ada separuh tapi tak jawab directly apa soalan saya. Ada orang lain nak tolong?
Due to the different concentration.
So what if you have different concentration? How does that help the recombination?
So the diffusion occur when the due to the different concentration of free carrier, right? So when LED is in the forward bias, for the current to flow, the free carrier in P type and N type will need to diffuse to move to each other. So in the diffusion region, there will be a recombination when free carrier meet each other.
Okay, so why do you let me make it clear. Why don't we operate the LED in reverse bias? Why does it have to be in forward bias? Or can we operate the LED in reverse bias?
we operate the LED in reverse bias, it will not generate the light.
Yes, why? So now why in forward bias?
I think because the forward bias has higher recombination efficiency compared to reverse bias.
How?
Because in forward bias, the depletion region is smaller.
The what?
Depletion region is smaller.
Does depletion region have anything to do with recombination? How does that help?
When it is smaller, the recombination can be more easier.
How is it easier? Because it doesn't make sense to me. So everything, you know, in semiconductor, it must make sense. It must be logical. So now I'm asking a very basic question. Why need to be diffused to have recombination? Senang je soalan saya sebenarnya. Cuba fikir logik sikit. Jawapan awak ada separuh. Sikit lagi sambung. Yang dulu-dulu lah. Tak lepas tu awak dah menyimpang ke sana ke sini. So
why diffusion is
why
needed?
we operate the LED in forward bias so that you have diffusion, right? That's the main reason.
Yes.
Otherwise, so why do we need to have diffusion in order for the recombination to occur? Why?
So that the free hole can meet the free electron.
Okay, continue a bit more. You're on the right path. Ihdinas siratal mustaqim, on the siratal mustaqim. Sikit lagi.
So the free hole in the p-type can
how do you create the free electron and free hole? How do you create the free electron and free hole?
Through diffusion.
Huh?
Through diffusion.
Yes. Alah awak ni. So basically, nak boleh jawab satu soalan setengah jam kita ambil. Tapi you know that is how when I was in UK, my lecturer rarely give answers. Dia akan buat macam ni dia akan tanya soalan sampai kita akan berasak kepala fikir sebab we have to think he will not give the answer. So basically, it's very simple. Then after you go and when I ask question, this develop thinking process in you. You should think. You don't memorize. So basically, why LED in forward bias? Because in order for you to have recombination, so the key is recombination, right? For it to go through recombination, you need the free carriers. Okay. So there are few methods of having a free carriers. You can have generation to create free carriers, right? So then we learned before you can use generation process to get free carrier. But in the LED case, you don't use the generation process. What you are using is you are creating the free carriers using diffusion, right? You actually using you're pumping from the battery outside to make the flow. So the free carrier will flow inside the what do you call it? The free carrier is actually coming from this. You cannot see my cursor. So the free carrier is coming from the N side going to the P side, and the whole from the P side going to the N side. So the free carrier are being supplied by the circuit, okay, by the circuit outside there. So that's how you get free carriers. And when you have a lot of free carriers, the recombination rate will increase. So if you only have a little, that's why if you put more battery voltage to the LED, you have brighter light because you have more free carriers moving inside the LED. Okay, I think that's enough. Let's have the second one. Thank you, brothers, for the good presentation. I hope the rest of you will understand. Brothers and sisters, make sure you be able to draw the forward bias LED. Memang wajib to be able to draw. Okay, next, let's call the next group. LED ada lagi ya? Tak ada. The next group is laser Anybody from laser here?
Madam, my teammate have therapy.
Yeah,
So,
it's okay. You will do it next week.
oh, okay.
So the laser. Who's doing laser here?
Me, laser.
Oh, you the teammate. You're doing laser with Afika.
Yes, with Afika.
Okay. The brothers are not. No brothers you doing laser except for Afi. Afi also not feeling well. Okay, then congratulations. We skip to the next one. Photo detector. Who's photo detector? Haha. Okay, brothers or sister?
Brother, madam.
Okay,
Kita orang.
teruskan brother. You have 20 minutes from now.
May on.
Sekejap. Okay. Set. Right. Saya Zarif.
Okay. Besar kan? Ya. Situ. Tak expand eh. Tu. Enable editing.
Ya, ya.
Okay. Assalamualaikum warahmatullahi wabarakatuh. So our group will be presenting about the photo detector. Okay, next slide. My name is Syed Zarif. So I will be presenting about what is photo detector. Photo detector is basically the key device in the front signal into an electrical signal. That's why it is known as the OE converter. The semiconductor photo detector is commonly referred as the photodiodes, where the photodiodes are the predominant types of photodetectors used in optical communications systems due to its characteristics, which are the small size, fast detection speed, and high detection efficiency. So next, Brother Me will explain how it works.
Okay. So basically, you can see that the photodiode works in the reverse bias. So from the picture, you can see that when we apply a reverse bias to the PN junction. So when we apply the reverse bias to the PN junction, the potential barrier accreditation will be increased. So as the consequences, the width of the depletion region will be increases also. So and then because we apply the reverse bias, there will be a strong electrical field at the depletion region. So there are no free electron and holes inside the depletion region. So when we illuminate, when we what they call tembak, when we shoot tembak, when we
Strike.
Image. Image.
No. When we
Right.
illuminated the photodiode, we illuminated photodiode with the light, and if the light energy is greater than the band gap energy. So the key point here is that when the light energy is greater than the band gap energy, the bonded electron from the valence band will be excited to the conduction band, leaving holes in their place in the valence band. So meaning that the process here, the key point that you need to understand is the light energy when the light energy is greater than the band gap energy. And then the bonded electron from the valence band will be excited. So here is the process that we use is the generation, and then it will when the electron excited, it will it will go to the conduction band, leaving holes in the valence band. So this electron holes pair process occurred through the all the layer here, all the three layer here, and then the under of the influence of electric field at the depletion layer, the holes will move to the here is mana
To the
here.
right.
So when the under the influence of the electric field at the depletion layer, the holes will move the holes will move to the P side. The hole will move to the P side at the valence band, and the electron will move to the N side and layer of the conduction band, and then it will create an electrical current flow called a photocurrent. So not the slide, not the slide. Ada lagi. Okay, so from the graph you can see that uh, there is one graph at the bottom. There is the dark current. So the dark current here is the leakage current, meaning that even if the photodiode is not even the photodiode is not illuminated by the light, there will be a leakage current called a dark current. So if we need to find the the total current, the total current in the photodiode, we need to add the photodiode current plus the dark current, so that we get the total current. So when we as you can see, we, the current increases with the light intensity. So meaning that if we increase the light, the current will increase also. So next slide. Take five. Okay, so so we will go to the performance parameter. There are several performance parameter that we need to understand. The first one is the quantum efficiency. Allahu Akbar. Okay, so the first one is the quantum efficiency, is the ratio of the incident photon that contribute to the photocurrent. We can say also the ratio of primary electron hole pair created. And the next one is the responsivity. The responsivity is the ratio of current of the ratio of current output to the light input. This also known as the efficiency of the photodiode or the sensitivity of the photodiode to the light. The next one is the capacitance of the detector. The capacitance of the detector is dependent upon the active area of the device and the reverse voltage across the device. It uses to determine the speed of the response of the photodiode. Meaning that here, the depletion width of the if we consider a reverse bias, the depletion width of the junction, if the more reverse bias applied, the depletion width of the junction will be increased, thus effectively reducing the junction capacitance and also increasing the response speed. And the last one is the response time needed for the photodiode to produce external current due to optical input response, meaning that how fast the photodiode will produce external current when we illuminated it with the light. Okay, that's all from me. Okay. Oops.
Lah. Okay, now is my part. Okay, in the photo detector, there is three types of devices that is used in photo detector. The first one is PN photo detector, which is the conventional one. The second one is PIN photo detector, and the third one is avalanche photo detector. Okay, let's move to the conventional one. Okay, for the PN photo detector, it is a conventional photo detector, which means it uses a normal energy. It has a normal energy band diagram, and it is consists of the casual PN junction. As you can see in the previous and the next slide, this is the left picture shows the structure of the PN photo detector. It is like the normal PN junction. And for the depletion region, it has a limited depletion region, which make this type of photo detector is inefficient for converting light to current, because the output current is low. Okay, move to the second type of photo detector, which is PIN. Okay, actually PIN photo detector is the alteration of the conventional one by adding the intrinsic layer in between the P type in between P layer and N layer. as you can see, it consists of an intrinsic region sandwich. It's like a sandwich between a heavily doped P regions. Okay, for this type of photodetector, the depletion layer is almost defined by the intrinsic region, and it has a large depletion area so that the current can be more easily generated. Why having a large depletion region can cause the current to be easily generated? As mentioned by Brother Muhaimin, when the PN or PIN junction is reverse bias, um, the when the photon emits at the structure of the PN structure, the atom will split into the electron hole pair, so that if the what we call that, the light is exceed the band gap, it's with the electron will excite to the conduction band. So after that, the electron from the p layer will move to the conduction band, and the holes from the valence band will move to the p layer. By using this PIN photodetector, why I said that PIN photodetector can cause more current to be generated, because um, by having a larger depletion region can cause having a strong electric field, so that the electron from the p layer can easily move to the n layer. Okay, move to the next type. Okay, the last type for this device is avalanche photodetector. Okay. Okay, basically, this kind of photodetector is similar to the PIN photodetector, but the avalanche application is applied to this type of photodetector. The output current for the conventional one and the output current for the conventional and PIN photodetector is actually small, which is around 100 microampere. So that in order to increase the output current, the avalanche application is applied. So basically, silicon is used in avalanche photodetector, and it gives up to 90% of efficiency, and for the gain, output gain, it can get up to 200, while for the conventional and PIN photodetector, it can get less than 1. But why this kind of avalanche photodetector is not widely used? Because in order to get higher gain or higher output current, it needs to use a bigger built-in voltage. So for this APD or avalanche photodetector, it requires around 100 to 200 volt. And the reason and the only reason where this type of photodetector is used is because when it is needed to be used in an application that is needed to have a very sensitive light. Okay, that is okay. Next is the additional information. As if I'm not mistaken, Madam has requested for our group to tell a bit about these two terms, which is the light absorption and transmitted. Okay, from what I know, light absorption, in the research paper, they don't usually call it as light absorption, but photon absorption. For what from what I understand, like let I give an example. Let's say that we have a solution, a structure. When we transmit a light into the structure, the light that pass through the structure is called a light transmitted, while the light that has been absorbed into the structure is called the light absorption. I think that's all from me. I'm passing the floor to the brother Haris.
Now I will talk about how we can use these photodiodes in our daily life. There are many applications for this. One of them is image sensors. So in an image sensors, depending on your resolution, each pixel will be assigned a photodiode each, and there are two types of image sensors right now. The first one is charge coupled devices, where each photodiode has their own pixel packet, and then they transfer the electrons first before they convert it into voltage. The next one is a CMOS sensor. The light will hit the photodiode, and then it will be immediately converted into voltage. Next is photodiodes are used in the receivers in optical communications. In the first picture on the left, we have strands of fiberglass. You can see the light passing through them. And on the right picture is a free space optical transmitter. So in both cases, they use light as a means to transfer data, but the fiber optic uses a wire, while the free space uses a laser itself to transmit data through air. And in both cases, they use a photodiode to convert the light into data. And in the next slide, photodiodes are also used in object and motion detection. So in the next slide, how it works, how it detects objects and motion is it first transmits a light, either a laser or UV or infrared, and then the photodetector will detect any light that is reflected off an object from the transmitted laser. Yeah, that's all for me.
So finish?
Now I pass the floor to brother Zarif again.
Oh, sorry. Okay, next for the Islamization. The verse here is from Surah An-Nur, ayat 35. The same verse from brother Hazim Salam used for his group. Allahu nurus samawati wal ard mathalu nurihi kamishkatin fiha misbahul misbah fi zujajati zujajah ka'annaha kawkabun duriyun yuqad min syajaratin
The
mubarakah
ayah is wrong.
zaitun. Oh,
The ayah is wrong.
oh,
The other,
what do you mean?
so no, they should.
Noros.
Fi zujaja, or the way you read is wrong.
Okay, okay.
Az-zujaja tu I thought the ayah, so read it. Can you read it properly?
Okay. Fi zujajati zujajah ka'annaha kawkabun duriyun yuqad min syajaratin mubarakah zaitunitin la syarqiyah wala gharbiyah yakadu zaituha yudi walau lam tamsashu narun nur ala nurin yahdillahu li nurihil rihi min man yasha wa yadribullahul amthala linnasi wallahu bikulli syai'in alim. Based on the verse here, it based on my point of view, this verse shows that the Allah Subhanahu wa Taala is an ultimate guidance for us. His light, which is the guidance, is bright that can shine our heart from being astray from the right path or direction. If we follow His light, we are safe in dunya and in akhirah. Imagine if we live in a dark world without sun and moonlight. Definitely we cannot survive in that world. This is the same situation where if there's no light, the photodiodes will not be possible. So whatever it is, we as Muslims, we must be grateful with Allah's creation and the knowledge that given down to us, which we can use His knowledge to make use His creation, which is the light, to implement it into creating the photodiodes so that we can use it to create various devices as well as new technology. So that's all from us. Thank you.
Okay, thank you very much. Can you stop sharing? All right, so thank you very much. I think spot on. We finish the class at 11:20. So the question and answer will be next class. So please get ready. You can watch your own presentation I'll put online. Because and then you maybe want to spot some mistakes that you kadang mungkin nervous kot. You know, things that you are not, you mistakenly mention something. So okay, and the rest of you, please have a get ready of a question for next week. And as I mentioned, we will not discuss this anymore. Finish here, it means in the final exam, as I mentioned, definitely there'll be question on this, right? On these topics. So make sure you understand and you'll be able to draw. I think the best if you can draw your own energy band diagram with hand there, because if just from a copy paste, if I ask you again, if I make a pop quiz, draw the energy band diagram of a LED, how the LED works. Can you do it or no? Or photo detector. So you should be able to draw. Okay. You need to know how, but it's simple. LED, you just need to be able to draw it forward bias, then do some explaining, and then the photo detector in reverse bias. Okay, great. I've jotted down some questions. No, actually a lot of questions for your group for next class. So be inshallah an interesting discussion and the rest of you also can ask. Okay, great. And also I just want to comment on the Islamization, because I didn't comment in the first group. The Islamization, the second group is clearer. I can you direct, you in the end you have some relation of the ayah to the photo detector. Adalah. But the first group I don't see the relation of the ayah to the, you do the tafsir of the ayah, but how does that relate to LED is not clear. Okay, so if you want to rebut, you can have a think of it and then answer me next class at the first group. I still give you a chance to improve. So it should, the Islamization, what is Islamization, you should reflect on it, and it should be direct of the ayah to the or the ayah, the hadith, or the signs of Allah somewhere, you know, to the topic. And it can be, the topic can be everywhere, because the photo detector, for example, is huge. You can take one part of the photo detector and then relate it to the Islamic knowledge. It's not easy. So, but it shows that you need to have a ilham from Allah to get a high mark on this, right? So you can ask Allah to guide you. Okay, I think that's all. Thank you very much. Can we close with a doa, brother, please? One brother who ada yang tak baca lagi, tak pernah baca.
Madam.
Yeah.
Madam, so the quiz will be in Thursday. Since
Tuesday. Tuesday quiz on PH Junction lah. Itulah. Should I give you during the class or after the class or?
Move the quiz.
Madam. Thursday.
Quiz Thursday. Okay, quiz Thursday. Tu pun saya tak tahu boleh siap tak. Saya rasa hari Isnin pun takkan habis sebab do you have laser and solar cell? Laser tu payah nak faham. Kalau LED tu paling senang lah sebenarnya. Kalau LED laser tu you better concentrate when your friend explain about laser because it's not easy. Okay, so maybe it will drag into Thursday. Mungkin Thursday separuh ke dan separuh lagi boleh quiz ke. So we bring them. Okay. Alright. So, but good job. About the two groups actually, I'm quite happy. You went through the points that supposed to go through. Cuma I hope the rest of you understand lah. Sebab kalau tak faham, you will suffer. Okay. Alright. Mana brother nak baca doa?
Saya, Madam.
Okay, silakan Anas.
Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Allahumma inna nas'aluka ridhaka wal jannah wa na'udzu bika min sakhatika minan nar. Allahumma innaka 'afuwwun karim tuhibbul 'afwa fa'fu 'anna wa walidina wa li jami'il muslimina wal muslimat wal mu'minina wal mu'minat al ahya'i minhum wal amwat bi rahmatika ya arhamar rahimin. اللهم إنا نسألك علما نافعا ورزقا طيبا وعملا متقبلا. ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. دعواه فيها سبحانك اللهم وتحيته فيها سلام وآخر دعواهم أن الحمد لله رب العالمين.
Okay, thank you very much Anas. Let's close the class with Tasbih Kifarah and Surah Al-Asr. Subhanakallahumma bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asr. Innal insana lafi khusr illa allazina amanu wa amilus solihat wa tawasaw bil haqq wa tawasaw bis sabr. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.